The converse of Pythagoras' theorem. So let's try a trickier converse of Pythagoras' theorem question. In this one, we've got sides 2, square root 10, and 7. And we want to figure out if this is right angled. Before we start, which one of these do you think is the hypotenuse? 2, square root 10, or 7? The hypotenuse, well, one thing that will help is square root 10. If we put that on our calculator, we'll know that it's going to be more than 3, because 3 squared is 9, but less than 4, because 4 squared is 16. So it's going to be 3 points up. And the calculator tells us that it's about 3.2. There's digits after that. So the hypotenuse is this one. It is the 7 is the longest side. So we want to check if 2 squared plus square root 10 squared equals 7 squared. Sometimes you'll be given a diagram like this, but always remember the diagrams are probably not to scale. This might look like a right angle, and maybe it is, but maybe it isn't. We need to check to find out. So, let's check this part first. The 2 squared plus the square root 10 squared. So I've got 2 squared plus square root 10 squared. You know, this squared plus this squared. 2 squared is 4, because that's 2 times 2. Square root 10 squared. Well, squaring is the opposite of square rooting. So if I take the square root and then square it, I'm just going to get the same number back. So 2 squared is 4, and square root 10 squared is 10. Really important to step out the working as much as you can in this, because it's very easy to get confused. The 2 got squared, but this number ended up being 10. Anyway, 4 plus 10, well, that's 14. On the other side, I've got 7 squared, which is just 49. Is this triangle right angled? No, it is not, because this squared plus this squared should be the same as this squared, and it is not. So it is not a right angled triangle. Done. And that's how you do the trickier ones with square roots in them.